All right, let's take a look at volume of prisms and cylinders. So first, volume of prisms, and we're going to analyze rectangular and triangular prisms. Volume has to do with definitely three-dimensional shapes, and it's how much something can contain, the space inside, rather, not distance, the space inside something. So how much space is, before we were looking at the surface area, which is the outside, we want to know how much space is now, if we were to skeletonize this, how much space is inside the entire prism, okay? So volume of a prism is given to us by the formula capital B times H. Capital B, like before, is the area of the base, and small h is the height of the prism. Now this formula is going to work to find the volume of any prism, whether it's rectangular, triangular, hexagonal, octagonal, whatever the case may be. It's going to work for any prism. Now, undoubtedly, you've already looked at finding the the volume of rectangular prisms, and you probably didn't necessarily call them that. You just said, all right, let's find the volume of this right here. And you did that by doing length times width times height. Volume equals length times width times height. That's what you're taught sometimes, and that's absolutely right. And I want you to see here where it fits into what we're doing. All right, first things first, we're going to base it off of the formula for all prisms. Volume equals the area of the base times the height. First thing we need to do is select a base. So like we did before, just to stay consistent, I'm going to choose the front rectangle, the front rectangle, this here, as my base. I'm going to sketch it out, and I'm going to label it, the bottom is 10 inches, and the distance going up the side here, as we see here and here, is 3 inches. Now, this is what I'm doing for capital B, correct? Capital B is the area of my base. So the area is length times width. So that's where the length times width comes in at. And then we just have height. So hopefully you can see the connection between rectangular prisms and the formula for all prisms. Okay, I hope that that is clear what's happening there. So let's just go ahead. Capital B is 3 times 10, which is 30 inches squared. The height is the number that was yet to be used, which in this case is 2 because of the base that we chose. So 2 inches. So now I just do volume is equal to capital B times H. 30 times 2, 60. This is going to be inches cubed. When we're talking about volume, it's units cubed. Area is always units squared. Volume is always units cubed. A way of remembering that is because volume has to do with the 3D shape. It has to do with a three-dimensional object, and it's the distance inside where we have a length, width, and height. So we're talking about 3 dimensions. It has to be cubed. Okay, so that's a very, very important thing. So here all we did, just recap before we go on to the next one, we said we used the original formula, capital B times H. When we did that, we noticed that capital B is just the area of the base, length times width. So we could just multiply those and we got 30. The number yet to be used is 2 for our height. 30 times 2 is 60 inches squared. Now let's just say real quick before we go on to part B, let's just say because we said, oh, this is a rectangular prism, I can use this formula. Let's see if we would have gotten the same answer. And I'll just kind of scribble it right here. Volume is equal to length times width times height. Only for rectangular prisms can you use that one. Length, 10. Width, 2. Height, 3. 10 times 2 is 20, times 3 is 60. So I'm still going to get the right answer. And notice it doesn't necessarily matter what you call your length, width, and height. If you're looking at it like that, that's the length, that's the width, that's the height. Because again, the commutative property multiplication, you can do them in any order. Okay, so knowing this new knowledge, for part B, we have a rectangular prism. So what I can do, if I'm asked to solve for the volume, I can go ahead and use the real formula, area of the base times the height, but I know that it's a rectangular prism, so really all I have to do is length times width times height. Length times width times height. My length is 7. My width going back is 8. And my height is 3. 7 times 8 is 56. 56 times 3 is 168. 168 centimeters cubed. Okay? So rectangular prisms aren't too bad because we can just use length times width times height. Now, because the area of a triangle doesn't meet that, we have to go back and use the real formula, capital B times H, which isn't really all that much harder based on the things that we have been doing. So let me write that again. Volume equals capital B times H, the area of the base times the height. My base, we said before, has to be this triangle. It has to be. So I'm going to draw my base out. And I'm going to label the parts they're telling me. This here is a right angle. It's 6 feet. This is 5 feet. And this long side, known as the hypotenuse, is 8 feet. The area of my base is going to be given by 1/2 base times height. 1/2, the base here is 5. The height is 6. 1/2 the base times the height is going to give me 15 feet squared. The other variable I need to solve for is h. So little h is the number not yet used. I used the 8, the 6, and the 5. Well, actually, I didn't use the 8. But still, the dimension for height is going to be this distance here going back, which is 2 feet. So now I have let's highlight with a different color. Capital B is 15 feet squared, small h is 2 feet. I can substitute them into the formula and solve. Volume is equal to capital B times h. Capital B is 15, h is 2. When I multiply, I get 30 feet squared. Oh, I'm sorry. I just told you we're doing volume. It has to be capital B is 15 feet squared. We found that right here. My h, my height of this prism, is 2 feet. 15 times 2 is 30, and because it's volume, I have to label it feet cubed. It has to be feet cubed. Okay, nice job. Alrighty, the very last bit, volume for a cylinder, it's going to be volume is equal to pi r squared h, and that's it. So it's the volume, pi r squared, we know that's circle, times the height, h, and that's it. Okay, so let's go ahead. Pi r squared h. I notice that my radius is labeled 2 inches, my height is labeled 5. So pi is 3.14. My radius is 2 squared and my height is 5. I'm going to do a little bit of mental math. I have to follow order of operations, so this 2 is what's squared only. So 2 squared is 4 times 5. Then I have 3.14 times 20. And now, if I just type that into my calculator, 3.14 times 20, I get 62.8. Label it inches cubed, and you're set. Okay, let's try letter B. Letter B, they're giving me, again, the radius is 4, the height, even though it's oriented that direction, is going to be 22 meters. So volume equals pi r squared h. Pi is 3.14. Radius is 4 squared, and my height is 22. Following order of operations, I have to square this 4 first, so I get 16. Then I have times 22. And now these are numbers I can't do in my head, so I'm going to just multiply 3.14 times 16 times 22. And my final answer is pretty big. It's 1,105.28. And this is meters cubed because we're doing volume. All right, last one. Part C. We're going to go ahead and solve for the volume, which is pi r squared h. Now, they're giving us the diameter, so just like we did on the other problem, we don't want the diameter, we only want the radius. So we're going to think of that as 5 inches instead. Pi is 3.14. My radius is now 5, so it's 5 squared, and my height is 4 inches. So it's going to be 3.14 times 25 times 4. Well, I know that 25 times 4 is 100, so this is 3.14 times 100. When I multiply anything by 100, I just move the decimal point. So my answer is 314 inches cubed. Inches cubed. I didn't even have to use a calculator. Okay? Nicely done, guys.